Hello everyone, this is Professor Chan for Math 1245 speaking. Today we're going to be going over section 3.6. 3.6 deals with polynomial inequalities and how to solve inequalities for the following. Okay, so I have an example of an inequality, and I can clearly see that I have degree 4 and degree x squared, and I need to solve essentially, right, what values will fulfill this inequality. And remember, what's an inequality, right? Inequalities is less than, greater than, less than or equal to, not greater than, not equal to. Okay, so the first thing I'm going to do is before I start, I always want to make sure I move everything to one side. One thing I do want to take note of is make sure that your highest degree is positive. And let me zoom in just so you can see a little bit better. Okay, sorry about that delay. So I have x to the fourth over x squared. And what's going to happen is the following. So what I'm going to do is I'm going to subtract x squared on both sides because I want my x to the fourth to be positive because it's the highest degree. So I have x to the fourth minus x squared is greater than 0. Okay? Once I get x to the fourth, x minus square on one side, right, and I have 0 on the other side of my inequality, what I'm then going to do is I'm going to factor, okay, right? Think about when we solve polynomial equations, we always generally factor or we use synthetic division, okay? So let's look at this. So I noticed that x fourth minus x squared, they both share an x squared. So I have a GCF of x squared. All right, I can pull that out. And I have x squared minus 1 is greater than 0. And I can factor that into x minus 1 and x plus 1 for the following. So make sure you factor everything all the way. Otherwise, you will not be able to solve this well. Okay? So remember, just like an equation, once I'm done factoring, I set all my factors equal to 0, right? So I set x squared equal to 0. I set x minus 1 equal to 0. And I set x plus 1 equal to 0. So I have x is equal to 1. I have x is equal to negative 1. And obviously, if I take a square root of 0, I'll get 0. So these are my three answers. Okay. Technically, I have 4 zeros, but if you notice, technically I have 4 answers, but if you notice when I have x equals 0, I have a multiplicity of 2. So if I have duplicates, I generally don't care about this when it comes to inequalities. Okay. So let's talk about the following right here. So what's the point in finding all these x values? These x values, what we're going to do is we're going to create a number line table. Okay. So how does this work? What I'm going to do here is I have x is equal to negative 1. And I want to go in ascending order. So I have x equals negative 1, x is equal to 0, and I have x is equal to 1. And I'm going from ascending order. And essentially, it's going to be kind of like a grid. Okay? So I'm going to look at, so essentially I'm going to have 4 boundaries. So I have negative, so I have these 4 spaces. And I'm going to write all my factors out to the left. So I have x minus 1, x squared, x plus 1 here. Okay? So let's talk about this right here. Okay? So what I'm going to do is I'm actually going to plug in numbers that fall within these number lines. Okay? So for example, let's take a look at this here. So let's say I'm going to think of a number less than -1, so I'm going to plug in, say, -2. Okay. Here is a number between -1 and 0, so I'm going to plug in -1/2. Here I'm going to plug in +1/2, and here, let's say we'll plug in 2. Okay. So I'm plugging in numbers in their respective fields, right, and it falls within my number line, right? My number line, remember, goes from smallest to largest, so it makes sense I'll plug in -2 because that will be the region that will be less than -1. So I'm going to plug in -2 in for x minus 1, and I get -3. Now, I don't care about the actual number. I care about whether it's positive or negative. So -3 is obviously negative. -1, -1/2 minus 1 is -1.5. That is negative. 1/2 minus 1 is -1/2, which is negative. And then 2 minus 1 is 1, which is positive 1. But we once again, we care about the sign, so we're just looking at positive. Okay? So does everyone see that? So notice I plugged in a specific number into my specific factor, and then I just care about whether it's negative or positive. Okay? So now let's look at x squared next. -2 squared is +4, so that's positive. -1/2 squared is +1/4, which is positive. 1/2 squared is 1/4, which is also positive. And then 2 squared is 4, which is positive. Okay. Now let's take a look at the last one. So plug in -2, I get negative. -1/2 plus 1 is +1/2. 1/2 plus 1 is positive. And then 2 plus 1 is 3, which is also positive. Okay. So make sure you write down all of your factors that supplement your entire inequality. Okay. So otherwise you're gonna miss pieces, and that's going to change your answers. So let's talk about what happens next. So once I'm done, I'm going to multiply my signs and see what my resulting sign will be. So I have positive times positive times positive. That's obviously positive. Negative times positive is negative. Negative times positive is negative. And negative times negative is positive times positive is positive. Okay? So some of you guys are wondering, why are we doing this, okay? So let's talk about this right here, okay? We are trying to find what? We're trying to find when x to the fourth, if I scroll all the way back up, when x to the fourth minus x squared is greater than 0. So if it's greater than 0, I'm actually trying to find when it's positive, okay? So let me scroll down. Okay, so if I look at where it's positive, I'm going to circle this in blue. I have the following. This is positive right here, and this is positive right here. What I'm going to do is I'm going to look at the boundaries of when it's positive, and I'm going to write this in interval notation. So if you look at this right here, right, it ends at -1. Okay. The thing that we also have to realize is, notice this says greater than 0. So obviously -1 will not be part of my answer, because if I hit -1, it will actually turn it to be 0. So this interval is going from -infinity to -1. I don't do bracket because I'm not including -1. I'll use parentheses because, let me write this back up. Right, this is what I want. I want to figure out when it's greater than 0. Okay, remember, -1, 0, and 1, if I plug them in, will give me 0. Everything else will either turn positive or negative. Okay, so here, the second positive sign, notice that it starts from 1, and then it keeps going to the right. Okay, yeah, again, think of it as a regular number table, right? So as you're going to the right, you're going towards infinity. As you go towards the left, you're approaching -infinity. So this is going to be from 1 to infinity, and that will be your answer. And then make sure you do union, so because we're saying it's negative infinity, negative 1, as well as 1 to infinity here. So this is your final answer right here. Okay. So take some time to kind of process this, and we're going to do a couple more problems. Okay, so let's look at a couple more. I'm going to do number 1. Yeah, let's look at number 1 here. So same thing, I'm going to move everything to one side so that I have just 0 by itself. So I'm going to subtract this, I'm going to move this over to the left. Okay. Because it's a fraction, it actually doesn't matter which way you go about things. Okay, but if it's a polynomial, right, you want to figure out which degree is higher. And then that one, remember, must stay positive. Okay, so what I'm next going to do, okay, let's remember how to combine fractions, right, for the following here. So let's talk about this here. This one, some of you guys may kind of forgot how to do this, but in order to combine these two, okay, right, we want to make sure they have the same denominator. So I have x minus 2 here. Okay, 3x minus 9, I can pull out a 3. And then x minus 2, let's talk about this. So I'm going to look at these two. And I want to see what they're missing. So notice x minus 2 is missing a 3. And it's missing a... Sorry, my apologies. When I factor this, this should be x minus 3. Let me correct that. And then... So let me rephrase that again. So x minus 2, if I'm comparing the two to each other, notice x minus 2 is missing a 3 and then an x minus 3. And then if I look it to the right, I'm like, oh wait, this one is missing a x minus 2. Okay, this is called my least common denominator. Okay, how do I know I have the right least common denominator? Is if you notice after I kind of add what I'm missing to the list for both of them, they should have the exact same items. And that's what makes it a least common denominator. Okay. People who are taking Math 945, please practice this. This is something that you should went over. So hopefully you guys should know this pretty well. Okay. So what I'm going to do is, if you remember, what I'm going to do here is I want to combine them. So it's one fraction. So 1x minus 2. So I'm going to multiply the first one by 3 over x minus 3, 3x minus 3. And the one on the right, I'm going to multiply top and bottom by x minus 2. Now, a quick reminder, when you are multiplying fractions, in this case, rational fractions, or rational expressions, which are essentially fractions that have polynomials on top and bottom. Okay, when you're combining fractions, you do not actually need to multiply the bottom part out. Just leave it alone. So the bottom part is going to look like this, right? It's going to be 3 times x minus 3 times x minus 2. And then same thing here. Okay, does everyone see that? So all I'm doing is I'm not actually multiplying them out. I'm just kind of combining them together. I'm putting them next to each other. So I'm just putting all my factors right next to each other. Now here, I will actually have to multiply the top part. So this is 2x minus 4. And then here, if I multiply this out, this is 3x minus 9. Okay. Now be really careful when you combine this. So notice you're subtracting both of them. So I have 3x minus 2x, and that gives me x. But then the part here will be negative 9 minus negative 4, so that's plus. So it's really negative 9 plus 4, and that gives me negative 5. Okay? And then I have one fraction, okay, which is what I want. Yeah, so if you have multiple fractions in your inequalities, what you need to do is you need to make sure you combine them as one. Then you can start doing your number line table. Okay? Now, when I have a fraction, I always want to look at both the factors on top and the factors on the bottom. Okay? So, this is what I'm going to do. I'm going to set all these equal to 0. So I'm going to set x minus 5 equal to 0, x minus 3 equals 0, x minus 2 equals 0. So I have x is equal to 5, x is equal to 3, x is equal to 2. Okay? I don't need to set the 3 equal to 0, right? Because obviously you can't do that. Okay? So this is what I'm going to do next. Let me kind of draw a boundary line. So I'm going to do the same thing. Make sure you go in order. So I'm going to do this vertical bar. So I have x is equal to 2. Let me actually shift this a little bit more. So I have x is equal to 2. I have x is equal to 3. And I have x is equal to 5. Okay. Let me move this. Here we go. Okay. So remember what I'm going to do next is I'm going to write all my factors out, right? So both top and bottom. So I have 3, x minus 3, x minus 5, and x minus 2. And then what I'm going to do is I'm going to plug in numbers. Okay, so number less than 2, I can plug in 0. Number between 2 and 3, I can do 2.5. Here I could plug in 4, and then here I can plug in 6. Now remember, once again, I don't care about the actual number value at the end. All I care about is a sign. So let's look at 3. 3, if I plug in 0, I get positive. And actually, if I plug all of them, it's always going to be positive 3, right? Because I'm not plugging in an x value. Let's do x minus 3. So I'm going to do 0 minus 3. It's negative. 2.5 minus 3 is negative. 4 minus 3 is positive. And 6 minus 3 is positive. Okay? And then this one is going to be negative, 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 and positive. And this one's going to be negative, positive, positive, positive. So once we're done, remember what we're going to do is we're going to multiply all our signs. So the very last column, multiply will be positive. Multiply my third last column will be negative. Multiply my second column will be positive. Multiply my first column will be negative. Okay. Now, remember, look at your inequality. So if I look at my inequality, I'm focused on the following. Let me do a different color. Let's do pink, okay? Or let's do orange, okay? So if you look at my inequality, I am looking at when it's less than 0 or when it's negative. So if I look at my grid, I care about the negative attributes, which is this. Okay? So what I'm now going to do is I'm going to do the following here. So I'm going to write this in interval notation. So this is going to be the following. The left-hand side is going to be negative infinity to 2, and then union. Now this one is going to go from 3 to 5. The reason why we do parentheses is because we're doing less than, right? So we're not actually including the number here. Okay. So let's look at the next example right here. Okay, so let's look at this one right here. I want to show you this one right here because notice this time we have a greater than or equal to 0. Nice thing for us is, if you notice, it's already all on one side and it's combined as one fraction. So we actually don't need to do the moving. And actually, for the most part, it's factored most of the fraction. The only thing I need to factor is, if I look at the very bottom, I realize, oh wait, this is x minus 1, x plus 1. Okay? So yeah, be really careful. Okay? Remember, x minus 2 quantity squared is the same thing as x minus 2 times x minus 2 as well. Okay? So now everything is factored. I'm going to set each one equal to 0. So I'm going to set x minus 2 equals 0, x minus 1 equals 0, and x plus 1 is equal to 0. So this is x is equal to 1. This is x is equal to negative 1. And this is x is equal to 2. Okay, I don't need to do the x minus 2 twice, right, because that's just a duplicate. So let's do the following right here. Okay, so I have negative 1, I have 1, and I have 2. Write all my factors down. So I can do the following. I'm going to do x minus 2. And I can just do it as a quantity square. And I have x minus 1, x plus 1, right? So I'll plug in numbers like negative 2, 0, 1.5, and 3. Okay. Now let's look at this here. X minus 2 quantity square. If you think about this here, no matter what I plug in, it will always become positive. Okay, so I'll do positive, 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 positive. Okay. Now you could, if you wanted to. Some of you guys are like, why can't you do x minus 2 and x minus 2? You can. There's nothing wrong with that. So you could write 2 factors of x minus 2, and then if you multiply at the end, it actually won't change your results. Okay. X minus 1, it will be negative, positive, or sorry, this one will be negative still, my bad. But the other two are positive. And then the last one here is going to be negative, and then the rest are positive here. Okay. Let me double check. Yeah, 1.5 minus 1 is positive 1/2. Yep. And same thing here. Okay, so we're going to multiply our signs. So it'll be positive, negative, positive, and positive. Okay. Now, notice it's greater than or equal to 0, so I'm focused on here. And I'm focused on here. Okay. So let's take a look at this right here. Okay, now this is where it gets a little tricky, right? So normally, if you remember back in your inequalities, if I have greater than or equal to, or less than or equal to, remember I do brackets, right? Because brackets include my inequality, right? So naturally, some of you guys are like, why? Because this one should be negative infinity to negative 1. But we're actually not going to do brackets, we're going to do parentheses. Now, why is that? Okay, so let me explain why. Notice negative x minus 1 and x plus 1 are on the bottom. So if I plug in negative 1, right, I'll have negative 1 plus 1, which will become 0. 0 times x minus 1 will be 0. So I'm actually having a 0 in my denominator. And if you remember, if I divide things by 0, it becomes undefined. So even though technically negative 1, we're including 0, the problem is, right, it actually makes it undefined, and we can't count an undefined. Okay? So here, this would be from 1 to infinity because of the same situation, okay? It's not going to be bracket because if I plug in 1, I do 1 minus 1, which is 0, and I'm dividing by 0, okay? For the following, right? And so the reason why is because this is undefined and undefined, okay? Now, let me kind of explain this. Now, let's say if it was positive from 2 to infinity, I would do brackets, because if you go to your 2, notice a 2 is 0 on the top, and 0 on the top is okay, right? You can divide with a 0 on top, but you cannot divide by 0, or you cannot have a 0 on the bottom, okay? Okay. Yeah, so let's look at one last example. And then we'll call it a day for 3.6. Let's look at something like number 4. Okay? So I'm going to subtract, let's go this way. Okay, and also let me explain this once again. When it comes to fractions, we actually don't care which way we subtract, but if it's a polynomial, right, make sure your highest degree is positive. Okay, so I'll subtract. I have 1 minus x minus 4 over 2x plus 4. And that is going to equal to 0, right? I'm moving everything over, so the left-hand side becomes 0. How do I combine this? This one's not bad. Multiply top and bottom by 2x plus 4. So I have 2x plus 4 over 2x plus 4, right? Because if I divide it, that's just 1. Combine this, and this will be x. Be very careful this. 4 minus negative 4, that's a double negative, so it's plus 8. Okay. So when I get to here, let me rewrite this once again. When I get to this part, I'm going to pull out a 2, right? So the bottom part right here is going to be 2 times the quantity x plus 2. Okay, so make sure you factor everything out. Okay, let me erase the little mess up here. And then we can solve everything for x, right? So I'm going to set x plus 8 equals 0. I can set x plus 2 equals 0. So I have x equals negative 2 and x is equal to negative 8. Okay? And let me talk about this random 2 out here, right? This 2 right here, okay? You don't set it equal to 0, but you must put it back in your number line just so that you're including all your factors in your number line table. Okay, so let's get started. So we're going to need the same thing. This one's not bad. We only have 2 posts. So I have 2 vertical posts. I have x equals negative 8, and I have x is equal to negative 2. Okay, I'm going to write all my factors. So I have 2, x plus 2, x plus 8. 2 is pretty easy because it'll always be positive no matter what you plug in. X plus 2 will be negative, negative, positive. And then x plus 8. So any number below negative 8 will become negative. This will become positive. This will become positive. Okay? And remember, if you're kind of lost on this, remember, right, I'm just plugging in a random number for the following. So, right, I would plug in, say, like negative 9 I'll plug in, say, like -5, and I'll plug in 0. Okay. Doesn't have to be those specific numbers as long as they fit in your region, right? So the middle part, I have to plug in a number that's between -8 and -2. So if I want, I could plug in, say, something like -3. Okay. But once I'm done, I'm going to multiply it all out. So this will become positive, this will become negative, and this will become positive. And I look at my inequality. Let me use blue. And I notice I'm doing greater than or equal to. Okay. So I then realize that means I'm doing the positive signs here. Now be very careful of doing greater than equal to. So I will include as long as it doesn't end up being undefined. Okay. So let's take a look at this right here. This right here, if I look at this, it goes from -infinity to -8. So I do -infinity to -8. I will do bracket this time because if I plug in -8, that will only become 0 on the top. Okay? And it's bracket because I have less than or equal to. So normally, right, less than or equal to or greater than or equal to always use brackets unless it becomes undefined. Now -2, notice if I plug -2 here, it becomes undefined because it becomes 0 on the bottom. So this becomes parentheses -2, and it goes all the way up to infinity. And that's it. So make sure you write it in interval notation. So that concludes 3.6. If you have questions, let me know. But other than that, we'll come back and we'll start with 3.7.